What up?
Big mode.
Yeah. Everybody say big mode.
No.
Okay. Well, I was going to say something useful. Right, okay. So, survey. Yes. There's a Google form you can fill out if you have opinions. You're not required to have opinions, but you're allowed to. I think I might fill out the survey and say only live coding LaTeX is what I think I'm going to put in there. So if you don't fill out the survey, that might win, right? Anyways, so I was putting this thing together, and like when I designed this course, everyone in the universe except me seems to be of the opinion that you're supposed to give students time for in-class exercises. This is wrong. We all know this, right? What you really want to do is watch me talk, right? And see, I know this because I was raised on YouTube. Who else can't eat without YouTube? I just refuse to consume dinner unless YouTube is playing in front of me, right?
It's not. I mean,
yeah.
It's not worth. You might as well be doing two things at once instead
Right.
of one thing at once.
Right. I think like before Jenny Nicholson existed, I just didn't eat. Right. I was just on hunger strike until the Evermore bot came up line. Right. And so anyways, but I got this email from someone who's probably trying to sell me something. I'm not sure what, because I'm immune to marketing apparently. Who's like asking me all these questions about like the forms of pedagogy I used, right? Which is what we call everything now, even though the peda prefix means children, because we are all children of God. And by construction, right? So yeah, it said like, hey, are you unfathomably based, right? Do you do mental math in front of the students? Do you do monkey type? And then it said in there like, do you do like learning-based exercises in class time? And I was like, yes, but everyone hates it. So like, why do I have to do that? So my impression is there's big clustering in like EDU research around doing labs, and I succumbed to that pressure, and I want to apologize to you. I was wrong. We should never do anything in class other than listen to me talk, right? Yep, I got some nodding. Yeah, there's some chewing. That's good. Some people are looking nervous. Okay, and those are the three ways you can feel about something. Yep. Recognizing safety and liveness is not incorporated into this course. I usually teach this in the context of automata theory, which you can in fact teach in a cybersecurity course, but probably not a cryptography course, right? I think this is a really cool paper, so I put it in chat. If you want to see it in context, some of you are aware that I teach more than one class technically. This is topics cybersecurity, and probably one of these is about safety and liveness. I don't know which one. Probably this one. Does that look? Yeah. So we got a Bucci automata, which is a deterministic finite automata that does not halt. And you can do some automata theory. And anyways, you can partition these things and determine if the behavior you're describing is a safety or liveness property using a formal specification logic. This is really cool. This is, I regarded sort of formal specification as out of scope for this class, since this is sort of intended to be a systems programming class, right? But automata theory is lurking all around us at all times, right? It's like a, I don't know, it's like a metaphor. Okay. Today we are going to do actions, right? Lights, camera, action, right? Yeah. Camera, also 6 characters. Lights, also 6 characters, right? So we can do lights, camera, action. All of those are legal in this class. We cannot take multiple actions. We can only do a single action.
You say like lights, cameras, actions.
It has to be plural lights and singular camera and action.
And yes,
Yeah.
You do need
Please.
multiple lights for one camera.
lights, camera, action.
Maybe
No,
Right.
it's like lights with 2 S's.
Wait, with 2 S's? Like lights.
That's what I said.
Like plural.
Okay, no, I'm locked in now. That's slick.
Was it slick or slick?
Slick. So we're continuing the week off from C. I like to imagine this class as if we work on an offshore oil rig, right? We go out to sea for around 6 weeks. We work 80 hours a week in inhumane conditions. And then we come back and we do what everyone does in their recreational time off, learn DevOps, right? So it's perfect. It's just like real life. And so today we're going to do DevOps. And DevOps stands for Development Operations. The development is the people that develop code, and the operations are the people that have historically done IT. A lot of IT is being off-sited into cloud providers now. So DevOps is now based on this institutional framework or organizing framework known as infrastructure as code, where rather than having like a normal actual existing human maintain a bunch of Linux server farms somewhere in a basement that mysteriously go out and then the president blames a cyber attack but provides no evidence that a cyber attack occurred, right? Instead of doing that, you pay $1 trillion company an ungodly amount of money to use their servers every month, and you write little scripts that determine what those remote servers do, right? So these are both of these things are bad, and that's because computers are bad, right? Did you segfault, Jimmy? I heard the term segfault.
I just wrote a program that segfaults on purposes and indexes
Why?
to feel something.
I've been feeling sad a lot lately. That's become my preferred emotion. I don't know if anyone's really into that, but yeah, I love to be sad. Anyways, we're going to do some continuous integration today. Continuous integration is the first half of the CI/CD pipeline, which is the foundation of modern DevOps and is, in my view, one of the dominant ways and probably the emerging best way to develop software. We'll see if I'm right in 5 years. I was right about everything except Rust, which I refuse to believe anyone would actually voluntarily learn and is now the most beloved language in the world. So don't listen to me about anything. Okay, so I think some of you falsely claimed that some of the things I did last class seemed confusing, complicated, or hard to follow. Some of you alleged even it seemed ill-prepared. And I didn't think any of that was true, but it is interesting it came across that way. Because, I don't know, like, fundamentally, I don't understand a way to use the command line other than just, like, mashing a bunch of commands into it until one of them works. And so probably there's, like, a more systematic way to approach that. And turns out that way is continuous integration via YAML Markdown. So YAML variously stands for yet another Markdown language, and YAML's not a Markdown language. So it's both mutually recursive and contradictory. As all good names should be, right? In fact, even bad names should have both of those properties. And so maybe while we were typing all of those commands, and here, let's open up our most beloved Windows PowerShell. Can I hear it for the Windows PowerShell class?
Ooh.
That okay? Yeah, that was good. Some of you cheered and some of you didn't. That's ideal. And so I think I did something to the effect of podman run interactive terminal mount type. Yeah, was it type equals behind a space? Source equals dot target equals mount, and then you specify what you're running, which is we'll do Alpine, it's faster. And then you say, like, you run bin bash in there or something, right? Do you? You definitely don't need it on. Oh, okay, we got a podman machine in it. I thought I had to do both. All right, are we locking in? Ooh, it's configured in rootless mode. In that way, it is a lot like Yggdrasil, the world tree, which has roots, but they're not attached to anything.
So it's not rootless?
Well, are they truly roots if they're not in soil?
It has roots, but the roots aren't rooted.
It's unrooted.
It's unrooted. It's unmoored. It's adrift in the sea of life, much as are we all, right? By golly, it's Pinot and Natuzer I wonder what that is. It's my work. Oh, hey, we can cat my work. I did it, my work. Wait, really? Oh, it's, wait, oh, it's in mount up. Oh, there it is. Ah, look at it. Okay, so anyways, we did all that last class, and it was super cool and fun. Or according to this thing here that someone, not me, wrote, it was a hassle and a headache, and I don't like it. This is a run-on sentence. That's for effect, right?
It generated a time. It took 12 minutes.
What are you doing?
I was generating a 4096-bit time.
That's too big.
Yeah, oh, they took 12 minutes. That's not too bad.
Send me your code. Okay. So, I am thinking in the context of a DevOps paradigm I've heard of, but I haven't seen a lot of like textbook descriptions of, that is called build, test, deploy. Let's see an example of what this looks like. So this is one of the various websites I run just for school. A lot of you have probably been in school before, so you know what that's like, right? So this is the website I use to host the course materials on. And this has a build step that runs inside of GitHub, and it has a deploy step that runs inside of GitHub. Why is that bad? Well, every once in a while I push a change to live that is a breaking change that causes the website to go offline. And as soon as I do that, both of the students who actually do homework in this class email me instantly and say, Calvin, the website is down, right? And I say, what are you, a nerd, right? And they say, yes. And then they submit a pull request that fixes the website, right? And this is humiliating to me, right? So what I'm not supposed to be doing, right, is I'm not supposed to be doing just build and deploy, right? That's bad. That's bad. You're supposed to build, test, deploy. Do I know how to test? No, so we're going to build, deploy. Okay, so, psych, we're going to build, test. We're not going to deploy. I think build, test, deploy is the modern CI/CD tech stack. There doesn't seem to be the level of convergence on this as there is at this point around first waterfall and then agile as sort of dominant software engineering paradigms, right? And for the most part, I think the difference is that build, test, deploy can be done without the presence of a manager and the other ones cannot. So no one makes money from doing things this way except GitLab, which is a billion-dollar company, actually from Ukraine, of all places. So we're going to do CI, which stands for more than one thing. But in this case, it stands for continuous integration. So what is the continuous? In theory, the way this works is everything that we're thinking about here now in this framework is repository relative, right? So we're thinking in terms of the repository. The repository is ground truth for the code base we're thinking about. So what this means is that at every point in time, some tests have been performed over the code in a repository, and those tests are related to integration, to seeing if the code can come together in some way. Historically, at least when I was going through school, maybe 10 years ago, people talked a lot about unit tests and integration tests. As a rule, my impression is you now write a script that does all of the testing and is filed under the notion of continuous integration, right? So something happens to your code base every time you check something into the main branch on a repository. As a rule, this is done remotely on build servers. What is a build server? A build server is a server that's only purpose in life is to take code and turn it into software or a program or an executable. These live somewhere else. They are managed by GitHub, which is managed by Microsoft under the Azure framework. And so somewhere in the world, and we are not responsible for it, and if we were a large tech company, we would have to pay for a subscription to use more build power. As individuals, we don't use that many bits and bytes, so we don't have to pay anything. So there is some remote computer somewhere that is going to take the code you check into GitHub, and it is going to do something to it, right? In my case, the example flow I have set up today is going to take my SHA in C.C. It is going to compile it, and it is going to run the autograder over it, right? So that's what's going to happen on the remote server. My understanding is that this was initially developed by Google in the 2004 to 2008 window when they were building the cloud for the first time. and at that time it was called Site Reliability Engineering, and you can still find the textbook they wrote for Site Reliability Engineering online. They fell way behind open source very quickly because pretty soon Linux kernel went under this paradigm. And so now things like pandas are under build, test, deploy, and people make changes to pandas every 15 minutes, right? CI is one half of CI/CD. I'm not going to teach CD. Why is that? This is not a web class, and the thing that you deploy is a website, right? We're also not deploying packages, which is the next most likely thing you can deploy, right? So I think I've discussed with some of you the possibility that students at this university could take control of and maintain the base 85 package, perhaps in APT, right? That would be a case where we would do continuous integration. We would verify that base 85 builds on current Ubuntu, and then we would do continuous deployment, which is we would maintain a public URL that people can yoink base 85 from, right? It would have binaries at it, not just source code. So that's an example of a CI/CD framework. Another example of a CI/CD framework is Google Docs, which is continuously deployed and is available via sort of URLs. The next part of this is continuous. I think of continuous deployment. I have continuous delivery here. The cool thing about CI/CD for me is that I build a system once, and that system is the CI/CD pipeline. And that system is a piece of software that is responsible for taking code and producing software. It is software that creates software. It is meta software. It is higher order software, right? This is sort of the functional programming paradigm applied at the level of software design, right? And then separately, after I build that sort of infrastructure as code framework, over here I have some code base, and that code base defines the product, the software product I am deploying, right? And this is the development and operations. Operations is the CI/CD pipeline that takes code and produces software. And then development takes basically nothing and then writes code that generates software, right? So under continuous delivery, I am writing code, I am checking it into version control. Everything after I check it into version control occurs automatically on someone else's remote build server. Maybe I paid for it, maybe I configured it, but I do not think about it while I am writing the code that creates base 85 or Google Docs or like all the healthcare systems are on this, right? Epic. So I think of this as sort of a GitHub repository that has some intelligence to it, right? And I don't mean intelligence in terms of like necessarily the machine learning framework, right? It is capable of doing defined tasks. It is essentially, there is a command line that automatically runs in the sky somewhere. My claim is that this improves software quality and delivery speed. Citation needed on that. It's difficult to compare CI/CD to anything else because it only works for certain categories of things, but as far as we can tell, the highest quality software in the world is maintained under CI/CD right now, with the possible exception of some very old code bases that haven't moved on to Git yet, namely HTTP. Why am I teaching you CI/CD? My impression is that in academia in the United States, there has been no real significant response to every change to software engineering since 2007, which is sort of was a big year for Java and sort of when Java and Eclipse took over everything. My impression is most of the code written since 2007 is of ludicrously low quality. Many very serious mistakes were made in both hardware and software at that time. Firefox made the huge mistake that left them in a position of market vulnerability with regards to Spectre and Meltdown. A lot of the Windows OSs that were coming out of that time were terrible. There were no real improvements to the C programming language between C99 and C11 that led to a lot of instability. That's not true anymore. It looked to me like in 2020 all of the developers went home and stopped doing stupid things for no reason. And that's when we got Rust, and that's when we got DevOps. And now there's some extremely high quality technologies for producing extremely high quality software. This seems to be more popular abroad as well. As far as I can tell, and I don't speak either Hindi or Chinese, it looks like it is much more popular to use this in the developing software markets outside of the United States, right? So my claim is that we can determine that CI/CD is scientifically correct based on the relatively highest software quality operating systems, which is Ubuntu for responsiveness and FreeBSD for stability, both of which are maintained under a free and open source model. They are continuously available, and they are continuously tested, and they differ in this way from all of the Windows products and all of the Mac OS products, right? So if something that people made for free and give away is better than something made by $1 trillion company, we should look into and we should ask questions and we should inquire about what underlying changes caused that to happen. And my perception is the change in underlying methodology is that it is open source, which means everyone can look at the code, and it is maintained under version control, which means any changes to the code are documented publicly. So that is why I'm teaching you about CI/CD. I believe it is the correct way to write code. It is the correct way to develop programs and executables, and for such software as can be developed this way, which is not all software. You cannot develop flight software for an Airbus A380 using this technology, right? But if you can develop software in this way, I think this is the preferred methodology. Here are some things that I regard as in various ways being maintained under CI/CD, and the most important thing on here is probably PostgreSQL, which is GitHub native. Everything else on here moved on to GitHub over time. But if you just go to Postgres right now and look at that repository, right, there's continuous integration tests being run on every single check-in to that code base. And that's pretty cool. I think that's cool. I think that's an interesting way to solve the problem of how do I know if this change I made to the code actually makes it better or not. You deserve to have the power to do this. I'm assuming there are people that defend Agile and Waterfall. I have seen Agile most successfully defended in not the software development life cycle, but the systems development life cycle. So I mentioned I used Agile to put humans in space. My partner's using Agile to develop some GUIs that make semiconductor nanomaterials that make some form of thing. You can't really do that on GitHub, right? That doesn't really make sense. But if you make GUI professionally, you might do sprints. You know, so like Nickelodeon should be doing Agile, right? Yeah. So I found one case study. So I looked up what is the thing that the .NET framework is most famous for. And apparently it's being worse than a free version of itself. And the London Stock Exchange, people that love money. Who loves money? Yep, it's the root of much evil, but not all evil. That's a translation error. Check your Bible translation. It should probably say much evil, not all evil. I don't know Aramaic, but I did look into this a little bit because I was trying to figure out how evil I was, right? So, anyways, in 2008 or 9, I think, which was sort of this time I started around the 2007 was the big Java push. Microsoft was one of the first people to realize Java was going to explode, and they started doing full-speed development on C# at that time. And they were pushing the .NET framework very hard. And so Microsoft did a big branding exercise that their software engineering methodology was correct, and they did it around the .NET framework and the London Stock Exchange, which no longer uses Microsoft products, right? So the example Microsoft found of why you should not use CI/CD has these citations saying they were wrong. I am claiming I am more correct than Microsoft. I understand they have $4 trillion. I would rather not argue with them if I have to, but it is my responsibility to teach you, and my impression is that I should be teaching you CI/CD. Okay, fast forward 10 years, Microsoft is now just using Linux, which is hilarious because they are an operating systems company that makes the only real competitor with Linux because Macs don't exist, as we all know. And you all know that my favorite operating system is Microsoft Windows Subsystem for Linux, which is what Azure Linux is, right? So I love this. And fun fact, Azure Linux is maintained under CI/CD version control. Look. They check things, they deploy it. Like look at all these workflows. I don't even know what a workflow is. Oh, test coverage, deployment. Okay. Build, test, deploy. Okay. I think I only need to teach you build and test in this class. I don't think I want you to be releasing any of the executables you write publicly at this time. I think if you are interested in that, we should talk privately and we should decide what we're going to deploy, right? And we should be responsible about that in some ways. There's a lot of things that you can deploy. Some of you may have heard of Google Summer of Code, and that's how you spell Google. A lot of people don't know that. There's a common misconception that it doesn't have a P in the middle of the two O's. So if you want to do deployment, my impression is you should find a mentoring organization and do this. I don't know how this works. Oh, let's keep clicking. It took me backwards, didn't it? Wait, open source organizations. Open source organizations. Read more. Read more. We're trapped in a loop.
It's kind of hard to find
Upcoming
but
info
it's there
session.
somewhere.
It's somewhere.
It's somewhere. I looked at all the ones for this year.
They linked me to YouTube. I cannot watch that. I'm streaming. Get me out. Get me out.
I think you need to go to
In the previous
projects.
thing, there was
Projects.
No, that's wrong.
Oh, that is what I want to
You need go
do.
back somehow.
So why do we not do this one? Because it says Java, right? Why do we do this one? Because it says cloud, right? Very easy. Angular, yeah. Who loves Microsoft? Chromium, you can work for Google for free. Okay.
Awesome.
What else do we have in here? Does everyone like Flutter? I seem to remember people liking Flutter.
Ooh.
Go.
Everybody who knows.
Go, the good programming language, right? TensorFlow. Any data scientists? Really, none? There were like 10 of you in here on the first day. Did the data scientists stop coming to this class?
That was track.
I probably owe a lot of people a lot of apologies.
We would need a data scientist to analyze the situation.
Anyways, don't trust the data, trust me, the professor, right? Okay. So a while ago, I was writing a 4096-bit library, and every single change I made caused a new obscure error to take place, and it was really exhausting to find this. So what I did is exactly what you're supposed to do. I opened Python and wrote a testing script that tested my code every time I compiled it. And this was awesome and cool. And then I gave it to all of you as the autograder. That was just me implementing CI manually locally, right? I found a relatively hard problem. It had a few too many corner cases. I didn't want to remember all the corner cases myself. I have a day job, right? I'm a late night host in Portland, Oregon. And it's tough to be ready to do late night every night of the week, right? I actually only do 2 nights a week right now, but yeah, I go live on Twitch when I feel like it, right? And so I wrote this essentially a CI framework, and I used the understanding of this sort of software engineering methodology to allow myself to solve the systems programming problem, right? Because writing systems code is hard, right? So instead of doing things that are hard, I did something that was easy. I wrote Python, and then I did something else that was easy. I did what Python told me to do, right? I essentially outsourced the hard thinking tasks onto a different programming framework, right? And this was a successful way to solve hard problems, right? In practice, I mostly see this on GitHub issues and pull requests, right? If any of you are interested in joining the free and open source software thing, which I think is a good way to get a job and also a good way to have fun. I mentioned I do crossword puzzles for fun. That's kind of for like people that like natural languages, and I think all of us in here prefer constructed languages, so we'd probably rather write pandas. Yeah, boo, boo. What were we doing?
Boo, constructed languages.
Oh, for real?
The Wittgenstein class has got done a number on me.
Well, that makes sense. This is why we shouldn't allow undergraduates to study philosophy. They start getting ideas, right?
I agree now.
Grace, which crosswords do you do? Do you do LA Times? That's my fave.
I did the New York Times.
Oh, you do the New York Times? Doesn't that one cost money?
Yeah, but if you use your partner's Clark College account, it doesn't.
All right, so I need to start dating more broadly. Okay. Wait, this is recording. Chat clip that. Okay. Clark College is hiring. So,
I saw that.
yeah.
You could get a free
Crazy. As soon as I transferred here, they did a 4-year computer science.
They couldn't stand to lose you.
Oh.
That's crazy.
I think they should pay you royalties for that. But we're glad you're here. Anyways, before GitHub existed, people had to use this really, really annoying way of doing things. How many of you love email? Put your hand down.
Oh, my bad.
Yeah. So, anyways, I have this video of Linus Torvalds talking to the people at Google, and he's like, before we invented Git, we emailed around tarballs, which is like a zip file, right? And he's like, this was basically fine. And we're like, what do you mean basically fine, right? Like,
Isn't that still how the Linux kernel is?
no, it's on Git. It's on Git now. It's on GitHub.
No.
Yeah.
It uses email still, but they're not emailing Tarball.
Yeah.
Yeah, I guess, yeah.
Yeah, so all of the issues and pull requests are pushed out through email lists, right? Fun fact. Oh, I have an example. Look, it's from Linus Torvalds, a real person who actually exists. I assumed Linus Torvalds was a pseudonym, and then I saw a picture of this person. This is actually a real, live, actually existing person, right? I thought this was kind of like Elrond or something.
Classic Linus Torvalds.
Yeah, so anyways, I love playing to the crowd. I'm assuming that this is Linus Torvalds agreeing with Jimmy.
Yeah.
And so instead of paying Jimmy to be the TA, I pull up things that agree with Jimmy in class. And this is the form of compensation I provide for my TAs. If you would like to TA this class next year, hit me up and I will put some things in the slides that you like, right? So just let me know what you like. It's good for me to know what your opinions are. Most of the things in here are my opinions, right? So sometimes I put in someone else's opinion just to, even things out. Of course, all students have exactly my opinions because I'm so persuasive and such a good teacher, right? Yeah? Yeah, can I hear it for you all agreeing with me? Okay, good. You should be much more skeptical of me probably even than you already are. Okay. So CD does not stand for change directory. It does not stand for Calvin Deutschbein. It also does not stand for compact disk. It stands for either continuous delivery or continuous deployment. Let's see.
Professor Dalvin.
I do like Professor Dalvin. Continuous delivery or less often continuous deployment. What does Wikipedia know about the linguistic frequency of different subroutines? Come on, you're not computational linguistics. So we are going to CD from CD to CD, which is continuous delivery from the current directory to Calvin Deutschbein, which is what is happening when I read things off of my computer screen, right? I don't know, I think that's fun. Do you like, is this clever? Please clap. Hey, yeah, let's go. DevOps. Wait, what am I pressing? Okay. So one of the things you always have anxiety about as a computer science professor is that your students graduate and you all are students, and so you know that some of you don't have full-time job offers lined up for when you graduate, right? This is a source of stress and anxiety for me, just as it is for you, but like in different ways, but we are both stressed out by the same root cause, right? And so one of the things that often happens is students say, hey, look at all of these IT jobs. I have a computer science degree, I can work in IT. And there's nothing wrong with working in IT, but as a rule, you can get the highest paying IT job with an associate's degree or if you work hard with a high school diploma, right? And as a rule, students that attend a four-year university and graduate spent 4 years of tuition on something, right? So for me, it's my preference that you don't have to take an IT job unless that's what you want to do, right? Separately, I'm also not particularly good at teaching you IT, the information technologies things, right? So I understand the difference between a switch and a router, but I don't think about it every day, right? I understand how to image a physical device, but I don't think about it every day, right? This is a different skill set than the skill set of developing infrastructure as code or doing graph theory, which are like the things I do, right? But there was sort of always this tension that I never really liked, that like most computer scientists were just intellectually interested in IT and ways to solve that problem. To me, DevOps completely bridges that gap. There should not be barriers between people that like using computers and people that like using computers. We all only have friends that are computers, right? I saw a wonderful clip yesterday of someone talking to ChatGPT instead of their friends, right? And that's healthy. That's what we want to encourage as a society, right? So we want to break down barriers between different parts of the community of people that use computers, right? And to me, DevOps does this, and it's a good thing. People that write software should think about the operating systems that run on their build server. And people that run the operating systems on a build server should think about the software it's developing. We all want to be on the same team, and that is DevOps. And I think this is a beautiful thing when we all get to come together and do computer, which is one of my favorite things to do. This should also lead to better results because there's no longer information siloing, right? So people aren't confused about what type of software things are running on. Something that's always been nagging at the back of my consciousness is this semester I build these slide decks, right? I have outsourced the notion that my slides are going to be accessible to Posit, which maintains Quarto. I'm no longer performing my own web accessibility audits of my slides. I'm trusting someone else to do that. That makes me very nervous. Separately, if I didn't do that myself, I also don't trust myself to do those own accessibility guidelines, right? What I really want to do is I want to be situated in-house with the people that build my framework I'm using. And so we can all be on the same team, we can all talk about the same things, we can all make sure images have alt text and how we do that, right? So that is sort of a continuous development for me. I think of this usually in terms of the underlying technologies that are used. So I do not perceive in this class that we are using Ubuntu for development. We are using Ubuntu and the Ubuntu images for operations. We have a server that is running somewhere on which we conduct tests and run experiments, but the actual contributions of this class are not about using Ubuntu, right? Ubuntu is a facilitating technology, but it is not the subject of our study. I would argue, conversely, that GCC is very much the subject of our study, right? We are trying to develop things, we are trying to build executables, we are trying to understand those executables, and GCC is the technology that does that, right? But Ubuntu and GCC are not cleanly separable, and we see this when we try and run GCC on Alpine and it doesn't work, right? This is important and valuable. We should be thinking about what operating system we're running on top of, and we shouldn't have these sort of arbitrary abstraction boundaries at any point in the software cycle. What I think we should do is we should separate these things not culturally or politically, but we should separate them temporally. We should write down our expectations for our build servers at some point, and then we should go do development separately. But these things should always be kept in mind, and we can always iterate back and forth. I think of this as using tools to manage the code, not people. Linus Torvalds, our favorite person, who runs the Linux kernel, describes himself as managing code but not people. And I find this a very compelling way to think about using technologies. I, as a rule, do not like bossing people around unless they're undergraduates who are doing prime generation in class instead of paying attention, right? But if you have some code base that you're trying to use to solve a political or cultural or economic problem, right, it makes sense to have someone that is responsible for making sure that thing happens, right? So we can also think of this in terms of the I use the sort of implementation client distinction, which is not quite the same thing as the client-server distinction, right? Where there's people that use technologies and people that implement technologies. People that do continuous integration use the technology of operations. So we use Ubuntu, and we implement GCC or SHA or something like that. So we can think of this as, and I've often thought of this more strongly, specifically when we talk about, for example, data science versus computer science at this institution, right? To me, a computer scientist writes pandas, and a data scientist uses pandas, right? And we shouldn't necessarily view that as a distinction because the people that write pandas know how to use pandas, and the people that use pandas know how to write pandas, right? And so this DevOps framework is, I think, meaningful there to think about that. So we have continuous integration testing. We are integrating the ideas of client and server. And generally speaking, in this case, the ops part is running on top of either Docker or Podman. GitHub now, and does anyone know how long GitHub Actions and workflows have been around? Should I be asking you this? Does it even have a Wikipedia page? I don't know how long this has been around. It just showed up one day and I started using it. GitHub Actions is the facilitating technology that it's one of a couple facilitating technologies for CI/CD workflows. It is probably not the most popular, but it is the most free. The two competing technologies are Jenkins and GitLab, and there are probably others. I am most familiar with GitHub Actions because I've been on GitHub for years, and GitHub Actions showed up one day and I started fiddling around with it. GitHub Actions and GitHub Workflows are kind of the same thing, and I think of these as verbs attached to the noun of a repository, right? So historically, a repository was a bunch of bits that lived in the cloud. In addition to having those bits lived in the cloud, we have now attached computers to them, so they're no longer just hard drives, and those computers can run certain tasks. And those tasks are defined in scripts, and these scripts checks to see if the code, those bits, satisfy certain requirements. It does not look like this is set up particularly well for C, but I did in fact find a suggested workflow for C, and it was very easy to manipulate it and get it to work. So let's take a look at that. There is a hidden GitHub workflows folder and repos. Okay, and at this point in time, I think we're going to cut the screen in half. I'm navigating to GitHub/cdc89, which is what I use for this class/action. This is the repository I've built for today. I will put this in Discord, among other places. Oh no. And this repository I don't think is necessarily too interesting. It has a make file, which we're going to get to in a minute. It has a C file. Spoiler alert, this is my solution to one of the homeworks. If you still want it to be working on SHA 256, that's a little bit on you, but this is a solution, so be careful if you're looking at it. And then I have tester.sh, and this is the testing script that I included with SHA 256. I pulled these things out of the big crypto repository because I just wanted a slightly smaller and lighter weight repository to work with. Separately, I have this repository on my favorite operating system, Microsoft Windows Subsystem for Linux 2, Azure Linux. You notice that we say both Microsoft and Linux twice. That's called balance, right? That's me being fair. You notice how many times I say Mac OS? Do we have any Mac appreciators in here? Can I hear it for Mac OS? Yeah, woo, yeah, right, get hype. Okay, everyone loves Mac. So I have the, essentially the same, let's see. I have the same files present here, right? I have on action, I have a sample, I have solved, and so sample is the wrong version, which I need for testing. Solved is the correct version that I need for testing. I have a .c file and I have a tester.sh file. And then I also have this thing, .github workflows. This dot prefix means that this is a hidden folder or file. I can reveal it with ls.al. The A flag causes me to see everything, including hidden files. When I evaluate this script, you'll see that I also get .git, which is maintaining the GitHub repository, and .github, which is maintaining all of the things in this folder. And then we can also see the current directory dot and the next upper level directory dot. Okay, where is my brain? So there's going to be a hidden .github hidden folder. The hidden folder contains a non-hidden folder called workflows. GitHub-workflows, we can navigate into this. I can say cd.github. And I can see that I have a workflows, and I can navigate into workflows. Okay? And there's something in here, right? Okay. The workflows folder is going to have a variety of things in it that are related to triggers, jobs, and runners. Do you want to look at this in the browser or in the command line? Can I hear a whoop for browser?
Browser.
You want browser? I heard command line. All right, good choice. I love democracy. We'll just cat it. Okay. So there's triggers, jobs, steps, and runners. And these things are not necessarily as well labeled as I would like. This is a .yaml file. I kind of do want the syntax highlighting, actually. Should we have used Vimothy? Which window was it? Do we like that?
Better than cat. Oh, there are colons. Yeah, no.
We should actually unironically be opening this in VS Code, which is what it's intended to be done in. But am I going to admit we should use VS Code for something?
Never.
Correct. Okay, so what do we have here? We have triggers. The triggers are the events that start a workflow. In this case, I have push. That is a push action to the repository. So for example, I can come over here and I can git push. I think I have no changes to make, but we can make a nominal change. Let's vim shank. We'll delete nominal change again. We'll save that. We can git commit. We use the A flag because we want to commit everything without thinking about it, right? And we use the M flag to do a message. And what should our message be? Oh, I don't know, something like this. And then we git push, and that triggers a push event. That push event corresponds to a change to the code base. See, there is something that happened now. Oh, I don't know, something like this, and we have a little pending dot. I think that is burnt orange, perhaps? Yeah? Oh, we think it's brown? Okay. What can brown do for you? That's what I say.
What?
Leave my packages on display.
Okay. And so probably if we F5 this little friend here, maybe we'll get back some green. Ooh, we got upgraded to a green check mark. I like seeing green check marks. They make me happier, right? And so what that means is that some action occurred when we performed the commit or push event, right? Okay. That's not where I was. Where was I? I was living somewhere. I'm living right now. Okay. So the trigger is on push event. Then there are jobs and steps. I didn't find the distinction between jobs and steps that helpful or that informative. Basically, jobs are collections of verbs and steps are individual verbs. A step corresponds to one thing I would put in a command line. What is an example of one thing I would put in a command line? Perhaps gcc shank.c. Right? Okay. That's an example of one thing I could do. And that has some exit status, such as true or false. We can also have failures, which are denoted with a non-zero return value, right? So we have steps, and steps compose jobs. So we can put some steps together to form a jobs. An example of having a series of steps together, in my view, is cat tester. This is a series of commands that sort of all run at once. So I'm thinking of a script as being very similar to a job, and a step as being very similar to a command. And then the last thing to think about is runners. In my case, I specify a runs on command for my job. And this runs on command specify, wait, what did that, how'd I pop that up? I've never seen that before. That's crazy. That's so cool. What's happening?
I did a search multiple times.
It's because it's a smaller screen. Normally it'd be on the side.
It'd be on the side? Oh, that's cringe actually over there. Okay.
Wait, there's Copilot in.
Yeah. Yeah, but if you use it, you instantly go to jail. Remember, it's illegal.
Well, you probably have to have Copilot.
Cordova gave. Well,
Yeah.
Well, anyone can do it.
Yeah, I'm like mega licensed because I tell them I'm a professor and they give me
yeah,
everything for
Cordova
free.
said he got like 10,000 licenses that are seemingly indefinite, and so
Yeah.
he just was like, if you guys want one.
Yeah.
You gotta get all the students using it that way. when they
Yeah.
graduate.
First one's free. Okay. Strike that from the record. Let's get that off the record, please. Okay. Anyways, you run on a virtual machine or a container. In practice now, everything runs on containers. This thing here, we can actually see what this runs on. We're going to go back into Actions. I'm going to open it. Oh, I don't know. This is what a GitHub action looks like. We have a build command. We set up job. What's this do? We have a series of current runner versions, blah, blah, blah. We're specifying our operating system as Ubuntu. We're specifying our runner image. This image is on Docker Hub, probably. Let's see. Docker Hub Ubuntu. Docker Hub has fallen out of favor right now, but this is a way we can establish a baseline. Wow, this website is slow. Why is it slow? Is it always slow? So here's 24.04, and that's blah, blah, blah. Okay. So we're specifying that. These softwares live at some location, right? And you can just take a look at this, right? So here's a runner image. I don't know what we'd be looking at or caring about here, right? But kind of interesting. Has mini conda on it, right? Okay. We have a runner image provisioner. That's above my pay grade. We have a GitHub token. This is, you ask Professor Cordova, and then you get a pile of infinite money, right? Bunch of nonsense going on in here, but we do, for example, run some git commands, right? So here's using git init. This is initializing a local version of the repository related to the action, right? It's git is yelling at itself here, which is a little bit interesting. Let's see. Somewhere in here there's a Docker command, probably. Well, maybe not. I don't know. But anyways, when you set this up, you can click through here. You'll see there's a bunch of git stuff going on. A lot of getting, and I was pretty sure I'd see Docker in here somewhere. Did I just miss it? Yeah, I don't know. I think there's Docker in there somewhere. I don't know where it would be. GitHub does use Docker instead of Podman, which I found a little bit surprising, but I think Windows, Microsoft, and Docker are friends, and they run GitHub, so I think that's why they use it. So we have end-to-end a script specified in YAML, how I pronounce this. I think that's how everyone pronounces it. Do you say YAML? Yeah. Everyone? If you don't say YAML, you don't deserve rights. Okay. I don't know if you have to specify name. I was too scared to take it out, so I didn't do that. We have a trigger. We have jobs. The jobs have steps. And then these steps run on some runner, called runners because it's the thing that runs. And this is just the Ubuntu container. This is the same Ubuntu container we use inside Podman, right? Which is one of the reasons we used Podman containers. Okay, all right. Sorry, I'm fine. I'm not mad. CI is cool. Okay. So what happens here? We check out code from our repository. We install dependencies. Psych, we don't have any of those. Dependencies are for scrubs. We don't use any code that anyone else wrote. Now, does this instantly explode if you have to use libgmp, if you're like me, and it takes you 4,000 years to generate a prime number instead of you're like the TA and it takes you 5 minutes to generate a prime number? Yes. So I'm in big trouble, right? Because I have to manage my dependencies because I'm bad at writing code. Can I get some loud booing for me? Boo. Boo. That's right. That's what I like to hear. Right. And this can also run unit tests, and it can also build application artifacts, which are logs. You know what logs are? That's not what I meant to do at all. Oh no.
Control-Shift-T.
That works?
Yeah.
What a gamer move. Okay. We just chrono braked. Okay. So anyways, these are logs, right? So these logs persist somewhere. Why am I zoomed in? And there's many such logs, right? My impression is if you don't have the infinite pile of money academic license, you want to be careful about how many artifacts you make because GitHub starts charging you money at some point. That's a problem for future you to figure out, right? Because I have no idea to figure out how much money things cost when they don't cost me money, right? Yeah. Yeah, that's a problem for future you, right? And never me, right? The closest thing I have example of a continuous delivery, and in my case I do say continuous deployment, right, is I deploy a static website via GitHub Pages, right? And so that's that little deploy link we said there. I don't worry about that too much, and I'm pretty unhappy with my tool chain workflow there because it feels like I'm being intellectually lazy, and I want to do something that's really cool and fun. So someday I will solve that problem. But in the meantime, an example of a continuous delivery workflow is just using GitHub Pages, right? So you need CI/CD on your resume. Just get one of those websites up there, right? I think I made something called Wordish. Wait. Wordish. There it is. Oh, it's not quite Wordle. You can do some guesses.
In what way is it distinct from Wordle?
It's worse. But you can also play it as many times a day as you want. On every refresh, it picks a new word.
So it's better than Word.
So it's worse.
But when it doesn't have the I didn't program the event listener, so it doesn't log your keystrokes. You have to type in the box, which I think is disgusting.
You made it.
Yeah. which means I'm responsible for fixing it. Do I love JavaScript? Kind of.
Famously.
Yeah. I kind of. I did write this for fun, right? Yeah.
AOU.
The finished version runs in Node, and I don't want to pay for a server.
Is it?
Okay. Deploy to live. Okay. I don't know how much you can see, so I think I want to open this in a private window so I can see the same thing you're seeing. So this is a build event that occurred on the Machine Learning Grad School website. That is a separate website because it's forked from a different repository. It's forked from a Jamison Watts repository, you can see here. So this is a smaller, lighter weight website. It still takes 70 seconds to build, which I don't really know what GitHub's doing remotely. But again, they don't charge me money, so I don't care, right? And perhaps it's slow because I'm not paying money, right? And please load. What help? Okay. And you can see we have build deploy, right? And what is that? What is that? Is that an artifact with an SHA-256 digest? Crazy. If I didn't know better, I'd think I'm teaching you relevant skills in this class, but that can't be true because I'm an academic. Okay, so let's get out of here before we accidentally learn something and get us a job, right? Here inside the, there is a mention of Docker inside that end-to-end workflow, right? That's a Linux script running Docker on a device that Microsoft paid for that I get to use for free. So that does not convince me that you should be using Agile. That convinces me you should be using CI/CD. I suspect that if Microsoft had not acquired GitHub, they'd be running everything on Podman, but I don't know for sure, right? The Fedora people are running everything on Podman. It seems extremely stable, right? GitHub Pages is a little bit too automated for me. I think it's hard to learn things doing it, but I don't know another way to do this for free. You all have used GitHub Pages, probably? Yeah, it's fine, right? Like it's a good thing to play around with and learn. So instead of doing GitHub Pages in this class, we're going to do our own CI action for C. We're going to do that in the YAML file. Let me check the time. Let's see, we have, okay, all right. So there's more than one way to do things like this. You can use automatic built-in workflows that do everything for you automatically, or you can use the command line. Who loves the command line? I do. I don't know if you do, right? Yeah. Oh yeah, we got some command line appreciators in here. So let me give you our beginning reference thing. I did not find this easy to find. My impression is that the workflow documentation for things that are not web technologies, by which I mean not Node, maybe not Java, maybe not Python, they seem to kind of hide these things, right? This is the starter workflow I started with that I edited down to what I showed all of you. Let's make this, let's embiggen it. So there is a typo in here. This claims that there's a language called C++. We all know that's not true here, right? C++ isn't real and can't hurt us. This has more expansive triggers, and we're going to introduce a little bit of what the YAML notation looks like, right? Let's see. Where is... Yeah, I know. I hope I'm not getting...
You're in trouble.
I think Cordova's like in his office listening to me talk about .NET, and it was like, Calvin? I was like, I'm sorry, I'm opinion gifted, right? Like I'm allowed to have opinions, right?
Cordova is quite a fan of .NET.
I know. I am also a fan of .NET. I do think it is better than Java. Okay. So whenever I talk to Professor Cordova, I'm like, isn't it better than Java? And then we agree, right? And then we just go our separate ways, right? Which it is. I mean, C#'s a great language, and it's not my fault that people writing the TypeScript translator wrote it in Go, because they're .NET programmers that think Go is better than C#. Yes, Jimmy, what would
It's
you like?
not just C# that uses .NET. There are other languages.
Like Angular.
There's F#.
That's not Fortran, is it?
No, it's like a functional, like ML style programming language.
I'm intrigued. What's the theorem prover? Is Lean part of the workflow?
Part of .NET?
Yeah.
No.
Okay. That's standalone. Okay.
Lean is self-hosted.
Anyways, I love Microsoft.
I think so.
So here is what I started with. And so, yes, I want to point out this mistakenly says C, and it means It doesn't mean C, C sharp, it means C89, right? So let's go through our notes here and see what we have. So I have synchronized these two things across the screen, and so we can step through them. So I simplified this a lot, and actually we can pull them up side by side. What did I change? I changed the name. The name doesn't matter. I changed the trigger, right? So this is a much more expansive trigger. What makes this trigger more expansive? Well, you can specify which branch you use. I just use the main branch for everything because I'm the only person working on it, but it's common to have a development branch and then a deployment branch, right? That would happen if I was working on a bigger team, if I had to have public releases and different versions and different API adherences, right? It would make a lot of sense to have a development branch, right? And so, for example, Pandas has a development branch, right? And so you can specify default branch, so you can specify which branch. This also allows testing to run on pull requests. I was anticipating to receive no pull requests to the action repository. Maybe I'll receive some, right? They would come from you, so you'll know. But I don't automatically run tests on pull requests, right? But I could configure that. And the thing to point out here is once there is only one remaining specifier in a line, so these things are hierarchically nested, right? Then you can place it on the same line as the sort of colon. But if you have multiple things, you have to place them on their own line. So this is producing some sort of grammar, right? I borrowed Ubuntu latest. I think I specify all of these things, right? So we run on push. Oops, I'm on the wrong page. I conceptually perceive the job as similar to a .sh file. Why is that? Well, to me, this thing looks an awful lot like an sh command. That is a git checkout command, right? That I could not figure out what happened on previous versions. They switched everything over like 9 to 12 months ago, and they do not want you to use previous versions. And I think actually if you take out that at before, it just bricks. I think it refuses to do. So I'm assuming there was a security issue, right? When GitHub Actions first went live, a bunch of people started like running servers inside the Docker containers that were running the CI things and trying to get like free compute. So I'm assuming checkout is meant to prevent all of those things, right? So I perceive this as being very, very similar to a shell command. That's very similar to git checkout, which I think I can just evaluate here. And my branch is up to date, but that's checkout, right? So if I did not have this branch already locally, then that would grab the code. Okay. So then what do? I configure. It is expected in this command that I have some script called configure that I need to run, right? I did not have that in my repository, but something configure might do is it might get libgmp, right? Which do I have? Maybe. Is it not called libgmp? Do I have to put dev there? Do I have it? So I could have a configure file. The configure is quite similar to container files. So I could, I don't have any container files nearby. But oftentimes in our container files, we do things like we install GCC, and we install libgmp, and we install Vim, and we install Python, things of this nature, right? Make check and make dist check are all things that are going to come up later, but each of these are commands that I can run. And I do have them configured in this repository, so you can see what make does, right? Okay. So, not every Docker, and I assumed this, and I incorrectly assumed this. When I saw this thing said Ubuntu latest, I assumed I could put the name of any Docker container there. That is not true. Separately, that Ubuntu latest has GCC on it, which Ubuntu does not come with by default. So that Ubuntu latest is maintained by GitHub for development, and it has different stuff on it than Docker Ubuntu. So Podman run Ubuntu, and GitHub runs on Ubuntu latest are giving me different things. I don't love that, and there's ways around that depending on time this term, we'll try and deal with. But in the meantime, it looks like if you throw Ubuntu latest in here, you'll probably be fine. If you specify a certain version, right, eventually these versions will be sunset, and then all of your scripts will break, and you'll have to go in and fix them, right? And that's the ops part of DevOps. That's you having to go in and take care of your operating system, right? So here's the difference from Docker, which I showed you. They definitely don't bring over the rolling image and the development image. And so those are things that are not yet stable and not yet ready for public release, but you can test your code on, because it can be good to know what's coming down. Okay, so this is some built-in you can't change act. This runs make. Make is a command. I would like to make some effort to persuade you of the usefulness of learning a little bit of YAML. YAML is all over the place. It is most commonly used in the container space and the CI/CD DevOps space. It is also used in web design. These slides have a YAML header at the beginning that specifies how code is rendered. They specify that I use a monospace font, which I really appreciate, right? So these 3 letters line up with each other. Have you all seen YAML files in your data engineering or data management classes? Okay, that's reasonable.
I've seen that YAML.
You haven't seen this YAML?
No, I haven't seen.
Why? Were you? Never mind. Anyways, does anyone know how to speak French? I would like someone to try and say this.
Live.
So a lot of people don't know this, but the internet is actually named after the hit cinema release, Madam Web, which is what this web refers to here.
Fantastic piece of.
Yeah. I love art. Okay. You can fiddle around with GitHub Actions, and you are encouraged to do that, and I'm going to stop talking about GitHub Actions, CI/CD, and DevOps right now, and I'm going to go in a completely different direction and talk about Make for a while. Okay. So we have completed GitHub Actions. What was funny?
Why is it
Well, because we had to motivate Make with GitHub Actions, the dependencies.
Make is in GitHub.
Yeah, this made perfect sense to me.
Clearly in GitHub.
You're such a first chauvinist.
There was no time where you like show the checklist and change the order.
I've done that before as well, but only for reasons. I did that with Euclidean division, remember? I reordered it, because we had to do Bezos
Order things
first.
chronologically or top to bottom, like we did them in class.
I ordered it chronologically from bottom to top.
It's just inconsistent.
That's,
It's ordered chronologically. There's a total ordering over the events. And it is different than the YAML, but this is not YAML. This is Markdown.
It's different from the other slides, though. That's
fine. I didn't define an interface. I don't have to adhere to a public API. I didn't define a public API. This is all pre-release. Okay. Make is famous. CMake is the new version. CMake looks like a hassle. I don't really love it. I think you definitely have to use it for bigger projects, but you don't have to use it for anything we do in this class. Make is from 1976, which is consistent with everything we use in this class is older than I am, right? I don't want to teach you anything that's unstable, other than me. Okay, so what does make do? Make solves the problem. Do I have it up anywhere? Look at this thing. No mortal can successfully type this more than once in a row, right? No living human is capable of knowing the difference between type, bind, sork, dot, target, mount, alpine, right? That's not a complete sentence. You can't diagram that sentence. That's made up. No one knows what Pinot Orange Pickle is, right? Get out of here. Pinot Orange Pickle, right? So make is a way to store big commands. It's a way to store repeatedly used commands. It is a way to perform essentially code factorization on your shell scripting routines, right? It has a little bit of intelligence to it that we'll use a little bit more over time, where it can tell if files have been updated. So when you run a make command, oftentimes make commands are used to build executables based on code changes to .c files. Make is smart enough to look and see if the C files have changed. That's kind of useful. We're not really going to be using it that way today, but I think of make as being a shell command that is programmable via a make file. So we're going to build a minimal make file, and let's just start with this, and we'll follow through on a live code example. One of these is in Windows, and one of these is in Linux. Okay. Okay, so I have an existing make file in here, and I'm just going to move that to old file, and then we're going to create a new make file. I bet? Okay, very good. So we're going to vim makefile. And I am going to begin by writing a rule. These rules are going to look an awful lot like YAML, which we have previously introduced. So there's going to be a name for this rule. I don't totally know why it's called a rule, but it is. And I'm going to create something called build that runs gcc shank.c. I'm going to save and exit. Wait, did I say what I was calling this? That's fine, right? And we can cat makefile. And we can see that I have the same makefile over here on this screen as I do over here, right? So what can we do here? Do I need? Yeah, we can also nuke shank. Do we need to nuke shank? Yeah, let's do it. So I'm going to make a sha.c file that contains errors. I'm just going to not include standard IO. Void main print hi. Is that going to work? Cat shank. Okay, that should be fine. So if I were to run, for example, make, the command make, what does that do? Well, it's going to tell me what it does, which is it runs this command right here. And that command is the same command that I run under the build rule. So what is happening? Make is getting notice that it is supposed to make something. It is looking through its list of rules. It is picking the first rule, and it is running that rule. We can do the same thing by specifying a rule, make build, which will specifically look for that rule, but currently I only have one rule. This is giving me the exact same output as if I ran directly gcc shank.c. So this is a way to run code over time that sort of does the same thing. We should perceive this as useful to us because I have been encouraging us to, as a portion of our debug process, use this standard C89 and use things like, I don't know, wall, which even I don't remember if you're supposed to capitalize it or not, right? And so adding all of these sort of flags to your GCC is more likely to identify errors for you earlier. Many of the errors I think I saw in the midterm might have been detected by all of these flags, right? And so when we look at all those flags, oh yeah, you all did well in the midterm, right? Yeah? Lock in, great work. Big ups, uber slay. Does anyone still say uber slay, or just me? Just me? Am I? I think of myself as I am mass formation psychosis. Okay, so here is a way to use make to solve a problem. So let's vim our make file, and we can specify that we want standard equals, is it 2 slashes or 1? And it's lowercase c?
Yeah.
There you go, right? And so we're seeing sort of the same behavior, right? So this is useful to us. We get the same warnings. So essentially what's going on, makefile allows us to run shell commands. Does it allow us to run all shell commands? No. Internally it is running this thing. It's running bin sh. It's not running bin bash. That's going to matter in a minute. I didn't know that, so that has led to an error in the instruction in this course that I will have to address right now. Rules can be goofy. By default, the first one runs, and the first one is named build. Okay, so let's put in a second rule. What am I pressing? Oh, I'm in the wrong screen. Okay, let's vim makefile, and let's add another rule. I'm going to call this no warn. GCC shank.c w, which is going to silence all of the warnings. And you are allowed to start silencing warnings from GCC when you finish your doctorate. That's the rule, right? Okay. So everyone in here is going to get a doctorate in computer science, right? And become a CS professor at a small private liberal arts college in the Pacific Northwest, right? That's what I thought. Do as I do, not as I say. Okay. Oh my gosh, I even choked myself saying that. What were we doing?
Making something.
Look, no warnings.
That means it worked, right?
That means it worked. Let's check it. It worked. Just kidding, you can ignore all the warnings you want. The only thing that matters is that your code works, okay? Until you get a doctorate, then you have to start worrying about all this stuff. Okay. We can build. Oh, all the disasters are still there. Okay, that's bad. And then we can no warn. What happens if I just run make? We get the first one. I don't know, I think that's cool. Here's an example makefile. Let's see how we're going to do this. We're going to remove makefile. We're going to vim makefile. We're going to copy. We're going to do that. Okay. Make. Really? What did I do wrong? Oh, who even knows what I did wrong, right? Am I in insert mode? Where's my cursor? There it is. Ah! Okay. Oh, there's supposed to be tabs? Does that seem right? I'm assuming that's supposed to be a tab.
Your thing has underscores.
My thing has underscores?
Well, that seems like a.
That seems bad.
It's like highlighting that's basically attached.
Oh yeah, that's fine. This is what it's supposed to do, right? Okay, so remove yout. I additionally am specifying the name of the out file here, right? Let's see, what do I have? I have an old file, sample shank. Okay, so let's fix shank real quick. Include standard io.h. This has to be of int type. I'll put this on a new line. Add a return statement. That looks fine. And then I think, can I make? Cool, yeah, so that removed all the errors. And what it do, it created a shank, no.c, which I can run, and I can run that. Now, frequently, I don't want to keep my executables around because you don't want to store your executable as a rule under version control because you don't know what operating system it's going to run on. It might break. I try and only distribute source code because I don't want to maintain binaries. That seems complicated. That seems like the CD part of CD, right? I'm only doing CI. I would like to not have the executable in green around anymore. So I have programmed make clean to remove that executable, right? And so this is sort of the basis of the type of makefile I have been accustomed to using and working with. I will point out at this time both build and clean are 5 letters. It seems like there's some convention around using 5 letters. I see build, clean, and then also check is quite common. And then there's also things like make all. So I've tried to stick to the stylistic choice of having 5-letter rule names. I don't know how common that is. There's more to life than making everything the same number of letters. So let's implement a make check. We have a shell-friendly autograder. What I'm going to do now is I'm going to demonstrate that my current autograder is bad because it prints high no matter what. It does not print the SHA-256 sums. But I have an correct implementation under solved. So I can copy solved shank to the current directory. I can cat that. No. I can catch that and see my solution, which is probably correct. I don't know. You can look at this if you want to. I don't know, it's up to you. And I can test that, and I get no errors. So this notion of no errors is somewhat useful to us, and we get a 0 back, so that denotes there were no errors in our shell scripting. Now, what I would like to do is I would like to take this automated testing script and put it inside a makefile so I can make check. But there's one problem, and that problem is this thing right here. What's going on? Okay. This line runs just fine in bash. And it does not run in sh. These little things here, this is a subprocess, I think is what it's called. So that creates another shell, runs the command, and then returns the results. You can only do that in bash. You can't do that in sh. So I have to fix that. The convention and the way this has been described to me is make files can't do anything except work with the file system. So I can read from the file system and I can write to the file system, but I cannot create a command that returns something and then direct that into a previous command. It is possible pipes work. I don't know, I didn't try it. So I'm going to rework all of this so that it works in the context of a make file. This is banned. We're going to fix this. How are we going to fix this? The first couple lines, and we can look at this. Cat tester.sh. These are just echoes. These are all legal. This is the only stuff that's going to explode, right? And so we're going to solve that problem. And I've actually already solved that problem, so I'll show you here. Blah, blah, blah. You all know how curl works. Do you all know how curl works? Not to worry. On slide 54, I explain all of it to you. Yeah, I use curl all the time. Diff is uber useful. Diff compares the differences between two files. This is especially useful if you want to compute an SHA-256 sum and compare it to someone else's SHA-256 sum. Very good. Here's something that's interesting. I have something called austin.txt. This is the complete text of Pride and Prejudice. Nope, it's not. It's gone. Wait, is it not? Oh, I bet curl's not working. That's annoying.
I had a similar really weird issue with curl during SHA-256, and I never figured out what it was. It just wouldn't work from WSL. Yeah, I couldn't get that to work either.
We might just have to W-get it.
I think it was the curl that you put on the slides was wrong, maybe. I don't know. Actually, no. I think I figured out vib copy paste. Use that.
Well, we have it. So I used wget, which is more robust than curl. So if curl stops working, use wget. We're going to move page to austin.txt. Cat austin.txt. Okay, so that's a book, right? And what we can do is we can check the diff between austin.txt and austin.txt. There should be no differences. In fact, I don't know. And then when we see that, we can see that we return a 0. If there is a difference, we get a non-zero return value. So diff returns an error case in the case where two things are different. This is extremely useful to us. So how are we going to do this? Well, my plan was to Voltron together a bunch of diffs in a single command so that any failed diff returns a non-zero exit command, which triggers a failed build on my remote build server, right? So I rebuilt this into having a series of lines, and we can see those lines here in old file, which is my old make file. Let's not look at it here. We had a browser open, right? Ooh, computer slow. Computer slow. It's sleepy just like me. Okay. So what's going on here? I do 15 characters.text. I do lorem ipsum. I attempt to curl. It looks like this maybe doesn't work very often. I'm not opinionated about that, right? We have separately compiled. And so we then run all of the SHA-256 sums. We store 3 of the sums as inc, 3 of them as .sum, and then I take an OR over all of the diffs. Let's take a look at how that works in practice. There we go. Diff austin.txt, austin.txt, or diff 15 char lipsum. Does that work? Oh, apparently there's no difference. Wait, are they all broken? Cat lipsum. Okay, that's fine. That's odd. Oh, it has to be and, maybe? Anyways, you can do logical OR. And maybe I'm not realizing how logical OR works right now in my add-on state. But this can detect errors. And so in my end-to-end makefile, I generate a bunch of SHA-256 sums, 6 in particular, and then I compare them. And this will either return yes or no, depending on test failure or passage, right? So here is a case where we currently have an existing successful SHA. We can also break SHA and get a failure by running make. That compiled it. Okay. What else do I need to do? Is this the good shank? That looks fine. Okay, so we're going to take a bad shank, which is, how am I going to do that? That didn't work. Okay, we have something in sample, move, sample, shank dot cat shank. Okay, so I have, wait, is that also correct? ls sample. Oh my gosh. No, it needs to be cat, right?
You moved it.
Oh, I moved it? Oh, let's put it back.
You should probably copy it back instead, right?
Well, I don't know if I want to copy it back.
Because that way don't delete what you have.
I'm deleting it.
You don't have it anywhere. Now you don't have one.
Yeah. Well, I probably still have one unsolved, don't I?
Yeah, but that one is solved, right?
Yeah, well, I want a bad one. So let's just make a bad one real quick. Wait, no, we're trying to fail so that we can show a failure on GitHub.
You can just return one from main then, right?
Yes, probably. You think so? Think this will do it?
Yeah.
Okay. Make. Okay, make check. Wait, cat makefile. Oh, this is the old makefile. Okay, so we're gonna move makefile. No, we're gonna move old file to makefile. There we go. Big badness, right? Error 1, cool. Git status. We need to check. Nope, we need to make clean. Git status. There you go. We have an untracked file. Let's. We don't want that. Okay, git status. The error is good because we're trying to get an error on our remote build server.
Okay,
Yeah, that's an intended error.
right,
We're doing this as a silly joke.
of course.
Yeah.
It-
Let's commit all the changes. 'Tis but a jest. We're gonna push. I'm push when you're pull. I'm in when you're out. Right? Yeah. Everyone. Okay. Yep. Tis but a jest. Tis but a jest. Who would push a jest? Failure. And there you have it. According to Microsoft, I'm a failure. See you in 2 weeks.
That's just I might have a working base 85
Wait, what?
I have a working base 85 Rust now.
Cool.
Yeah.
So I think what you should do is you should do continuous integration testing against the base 85C in the Git repository. So you should somehow pull it from that. And you should do comparison testing against, like, we need some things to test over, right? Because what we want is if Git ever makes a change, you need to immediately have your repository explode so you're not pushing something that's
This one
non-compliant.
is from the ASCII 85 one.
Right. So another thing I was thinking is we probably want to have flags or something, or distribute both an ASCII and a base 85. I don't know.
Maybe. So
We need to look into
one
this.
that covers the ASCII 85, one that covers the Git one.
Yeah, I'm not
Okay,
sure.
Yeah. The one that I wrote also accepts all of the same flags that the ASCII 85 does.
Yeah.
Except for the decode one, because it does accept decode, but it doesn't do anything.
Okay. Anyways, we should look into this more, but I think the more relevant thing is the political problem of getting into APT, which is, I think, what makes you legitimate. To me, it's only intellectually interesting to have a base 85 that runs inside APT.
Another
so.
thing that could be possible, I don't know if